hit Algebra 2. It's Wednesday, November 11th. So this is your activating strategy, which is what do you notice? What do you wonder? So on this, all you're doing is you're recognizing kind of just like pieces of each graph and kind of comparing them. So I'm just going to give you a for instance, and you don't have to necessarily do this one, but this right here has a bounce, just like what we learned yesterday. And this one also has a bounce. And this one has a bounce. This one doesn't. That's all I have. So, the fact that they all touch at 3, they all share that. You know, they cross the x-axis at 3. That's also something. So really that's just, you know, what do you notice about these graphs? What can you tell me? Okay? All right, so we're still kind of continuing this whole concept of cross, bounce, and wiggle, okay? So if the multiplicity is odd, the function f of x crosses the x-axis at 0. So they say odd instead of just like 1 because if you have a degree of if you have a degree of 5, then it actually is just going to like cross. And we're going to see that more in just 1 second. Okay, so multiplicity is even, the function f of x bounces on the x-axis of 0. So let's draw a picture of what that actually looks like again. Remember cross, that means that it's just going to look kind of linear. It's going to cross through one point. And then a bounce is going to look more like a quadratic. Okay? All right, so on this one, we're trying to figure out what the degree is. Now, when you find the degree, you are either adding up, if it's in factored form, so that means that it has parentheses like this, and you can multiply it out. You're adding up the exponents. Okay, so 1 plus 1 plus 2. So 1 plus 1 plus 2 is 4. Okay? If it was written out in standard form, that means it was in descending exponent order. This would have an x to the 4th as your first leading coefficient or your highest degree. Okay, so that's also how you can tell. Now, zeros of this, what I would do is I would switch the sign for all of the ones that have an exponent of 1, or set all of these equal to 0 and solve is what we've been doing. So let's go ahead and do that. Set them all equal to 0, and then you're going to solve. So this will give you -9, and then this will give you -3. So there's going to be a point at -3, be like in here, -9. And then when we solve this, remember, in order to get rid of that squared, we're going to take the square root on both sides. And so that's going to give you x minus 4 equals 0, plus 4 plus 4. So x is going to equal 4. Now, we have a degree of 4, but we only have 3 solutions. But you notice how there's a 2 right here. This has a multiplicity of 2. So that means that we're going to have a bounce that happens. Yesterday we talked about positive and negative polynomials. This one is positive. So that means that it's going to look like an x to the 4th polynomial. It's going to be this like weird W shape. All right, so if I'm going to sketch this, what's going to happen is I'm going to go for the top, cross, and then I'm going to go through -3 and cross, and then I'm going to bounce at 4. I always start left to right when I draw these. So you have to kind of have those parent functions memorized. So parent functions meaning like x to the 2nd, what does x to the 3rd look like? What's x to the 4th look like? What's x to the 5th look like? Okay? So I know that an x to the 4th is going to look like a W shape. So that's why I can kind of draw this out. Now, if you're like, I don't want to memorize all of this stuff. Yeah, you can put it in your calculator. But again, there's going to be a point in time where you're not going to have your calculator and you're going to have to draw this based off of yourself. Okay? So this would look like this. and we can zoom out because you're not going to see it otherwise. So let's go ahead and look at the second one. If the multiplicity is odd, the function crosses x-axis at that 0. If the multiplicity is even, the function bounces that x-axis at that 0. So on this one, we've got a negative coefficient. So that changes a little bit. We're going to flip it upside down. So the degree is going to be 1 plus 2, which is 3. And so for zeros, we're going to set everything equal to 0. Now, you don't have to set negative 1/2 equal to 0. You don't have to do that. So you're just going to take what's inside the parentheses and set it equal to 0. But you can take along this negative 1/2 for this one if that makes you feel better. Okay, so the first thing you're going to do is divide by negative 1/2. And it just disappears because 0. So this will give you x equals negative 2. Over here, take the square root. Sorry. Add 2 to both sides. X equals 2. So there's going to be a point at x equals 2 and x equals negative 2. Now, x equals negative 2 has a cross. And this one has a bounce. And remember, this is a third degree polynomial. Okay, so if I had a third degree polynomial, let's just look at what it would normally look like. Looks like this. But we've got a negative one, so it's going to go the opposite direction. So we're going to go this way, go down. This one's going to cross. And then I'm going to come back up. And then this one's going to bounce. And for a negative third degree polynomial, you're always going to have an end behavior of this is going up on this side and going down on this side. The chart yesterday will help you memorize that. I would highly suggest writing that down. So if you missed yesterday, go back and watch that video. All right. So go ahead and pause the video, and I want you to identify the zeros and their multiplicities. Okay, so the way you're going to memorize or know the multiplicities is it a cross, is it a bounce, or is it a wiggle? All right, so you're going to pause and then check your work. All right, so the zeros of this function are where it crosses the x-axis. Okay, so we've got negative 3, 2, and 5. Okay, so at negative 3, is it a cross, wiggle, or bounce? Well, it's a cross, right? So we've got a multiplicity of 1. At x equals 2, is it a cross, wiggle, or bounce? It's a bounce, so that's a multiplicity of 2. At 5, do we have a does it a cross, wiggle, or bounce? Well, it looks like a cross, right? Okay, so it looks like a cross. So we're going to put a multiplicity of 1 right now. Okay, so what degree polynomial is this? Well, we can just take the multiplicity and add it up, right? So we got 1 plus 2 plus 1, which is 4. Don't worry about this last box. The reason why there's this last box is because 2 has a multiplicity of 2. Okay? So how do we write out the possible equation for this one? Now, remember, you're going to take each of these zeros and change the sign. And the multiplicities are going to be the exponents outside of the parentheses. So let's actually check this graph. Let's put in our graphing calculator. Let's see if it's exactly like what we've got on our paper. Okay, we're going to zoom in. All right, so it's something kind of similar. Now, this is stretched a little bit more, so I'd probably look at trying to compress this a little bit. So the number out front would probably change, though that like length, if you will. So, I mean, we could throw in a 2 out front. So I'm going to insert a 2 out front. And I want to see what that does to my graph. Well, that doesn't really help. But if I throw out a 0.5 or 1/2, and graph. Not quite. But that's what you would do. You would play around with that and you would try to figure out, all right, what's that stretch? What's that compression that you're going to use for this equation? Okay. Normally you're going to have answer choices that you can check and just plug into your graphing calculator. But that being said, this would be a possible equation, not necessarily completely accurate, right? All right, so for that independent practice, use the information provided to sketch a possible graph for the polynomial function described on the provided coordinate plane. The end behavior as x gets larger and larger in either the positive or the negative direction, that g of x, that just means y, gets larger and larger in the negative direction. So this means that your end behavior will be facing downwards on both ends. Okay? We've got a 4th degree polynomial, so this is going to look like a weird W upside down. And then we got zeros at this. So we've got -3, 4, and 6. Okay? So one of these has to be a bounce, and one of these has to be a cross. Okay, so you're just sketching a possible outcome. So I would probably say that this is a cross, this is a cross, and this is a bounce. Sorry, that's my dog. Okay? That's my possible sketch, but again, there could be more than one. That's a rough sketch. But there could be more than one. You could do something else. There could have been a bounce over here. Okay? That's totally fine as well. All right, I'll see you in the next part.